All right, let's do chapter 3. Okay, so it says find the average rate of change, and so we're going to do that by putting 1 into the equation to find it, because that's average rate of change is just the slope of a line from the point to point. So I'm going to put in -1 and figure out what I get. So I got 7 times -1 plus 3 times -1 quantity squared, which is -7, and -1 squared is 1 times 3 is +3, which is -4. And then we're going to do f of 2. So that's 7 times 2 plus 3 times 2 squared. So that's 14 plus 12, which is 26. And so that from -4 to 26, the change in y is 30. And the change in x from -1 to +2 is 3. So that's a 10. It's positive, so it's increasing. Number 2. We're supposed to find intercepts, blah, 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 blah. So to find intercepts, we can do factor. So we got 6x squared plus 13x minus 5. We can try 3x and 2x to start with. And we got to have 5 and 1. We're not sure where the 5 goes. If I put the 5 here, over here, it'll be 5 times 3, which is 15. If I make that a plus, it'll be plus 15. And then I would have to put a -1 here to make it -5. And a -1 times 2 would be -2x. And plus 15x is 13x. So that works. If I'm trying to find x-intercepts, this has got to be equal to 0. 0 for the y. So 3x minus 1 equal to 0, setting each one of these equal to 0, or 2x plus 5 equal to 0. Add 1 to both sides. Divide by 3. There's one x-intercept. 1/3 0. On this one, subtract 5 from both sides. Divide by 2. So that's -2.5 or -5/2. 0. Y-intercept, I put in 0 for the x's, which leaves only a -5. Line of symmetry. Well, it's halfway between the x-intercepts, so I can add them up and divide by 2. But I also can do, let's show you. If you couldn't factor, you can also do the quadratic formula. Let me do that. So that would be minus b. Let me write that. It's minus b plus or minus the square root b squared minus 4ac all over 2a. So the opposite of b, opposite of positive 13, is -13 plus or minus square root. 13 squared is 169 minus 4 times 6 is 24, minus 24 times a minus 5 is plus 120 over 2 times a, which is 12. 169 plus 120 is 289, and the square root of 289 is 17. So I have -13 plus 17, which is just 4, over 12, which is 1/3. Then I have -13 minus 17, which is -30 over 12, which is -5.5, because 6 goes in both of those. -5/2. Okay, the line of symmetry is x equal, it's equation. And it's minus b over 2a. Well, that's the first part of this quadratic formula. -13 over 12. To find the vertex, we plug that into the equation. So we're going to have 6 times negative 13 over 12 squared plus 13 times 13 over 12 and negative, and then minus 5. So 13 squared, a negative 13 times negative 13 is positive 169 times the 6 over 12 times 12 is 144. And then we're going to have minus 169 over 12. I got too many minuses, plus a minus that. And then minus 5. Well, 6 will go into 144 24 times. So I'd have to multiply this by 2, and I'd have negative 338 minus 338 24ths plus 169 24ths is a negative 169 24ths minus 5. 24 goes into 169. Let's see. Goes into 168, I think. Let's see. 24 times 6 is 144. 24 times 7 is 168. So this is negative 7 and 1/24. Minus 5 is negative 12 and 1/24. If I put in negative 13/12. So the fractions weren't pretty there. Now some of you use decimal values. Increasing, so this is a 6x squared, so it's a right side up, and so it's increasing from the vertex to the right. So from the negative 13/12 to infinity, it's increasing. And it's decreasing from negative infinity up to the 13/12. So there's that one. Fortunately, this one's easier, even though some of you wanted to make it harder. X-intercepts. You put 0 in for the y, and you get negative 0.5 times the quantity x plus 2 squared plus 4.5. To solve for x, you subtract 4.5 from both sides. Divide by the negative 0.5. And half goes into 44.5 9 times, and negative divided by negative is positive. To get rid of the square, we take the square root of both sides, and the square root of 9 is plus or minus 3. Subtract 2 from both sides, and we get minus 2 plus 3, or minus 2 minus 3 for x. So the x-intercepts are minus 2 plus 3 is 1, and minus 2 minus 3 is negative 5. The y-intercept, we put in 0 for the x's. So we'd have the g of x, or the y, is equal to negative 0.5 times 0 plus 2, which is 2, squared plus 4.5. Well, 2 squared is 4, times a half is 2, times a negative, so it's negative 2 plus 4.5, which is 2.5 when x was 0. Line of symmetry. Well, that's pretty easy because this thing is moved left 2 and up 4.5. So the vertex is -2 up 4.5. And the line of symmetry is x equals -2. X equal because it's a line. And it increases. Let's see, this is an upside down because it's got a negative in front here. So it's upside down, so it increases from -infinity up to the vertex. So from -infinity up to -2, it's increasing. And after -2 to infinity, it starts going downhill. And that's page 1. Page 2. So we have a positive parabola, and we have a line with a -2 slope. They're going to hit in 2 places. We're going to find those by setting these equations equal. X squared minus 5x equal -2x plus 10. Well, I want to keep the x squared positive, so I'm going to add 2x to both sides, and I'm going to get x squared minus 3x. Subtract 10 from both sides. Minus 10 equals 0. Now I could plug this into the quadratic formula and get an answer, but I can also factor this. This is going to be x and x. And to get 10, it'll be 2 and 5. And if I make it minus 5 by putting a minus there and plus 2, that'll make it minus 10. And it'll make minus 5x and plus 2x, which is minus 3x. So I set these equal to 0, and x is going to be x plus 2 equals 0, so x equals -2. Setting that equal to 0, and I get x minus 5 equals 0. Add 5, and I get x equal 5. But I want the points of intersection. Well, when x is minus 2 and 5, so x must be -2 here and plus 5 here, because this is to the left. -2 something, and this one's at 5 something. Now if I put -2 into either side, x squared minus 5x, and put -2 in there, I'm going to get -2 squared minus 5 times -2. So I get 4 plus 10 is 14. If I put the -2 on the other side, I'm going to have -2 times -2, which is 4 plus 10, 14. So that one worked. And probably if I put 5 into both of them, it should work. That would be 25 minus 25 is 0. Or -2 times 5 is -10 plus 10, 0. So I get 0. So the intersection points are the -2, 14, and the 5, 0. That's the answer to part A. Now that I've done all this and got this picture, it's easy to be, when is the parabola less than? Below the line. G is the line. The parabola is below, between -2 and 5, and so my answer, and it says it could be equal, so I'm going to say from -2 to 5. And there's the answer to that one. Now I have an equation that the lettering is all out of order here, so I'm going to write this as x squared plus 6x plus 7 and get it in proper order. And that's what f of x is. And since it's a positive x squared, I know it's going to go like this, and so it's going to have a minimum. Now where that minimum is going to be on the line of symmetry, which is what part B asks, which is minus b over 2a, so it's going to be the opposite of 6 is -6 over 2 times 1 is 2, so that's -3. So x equal -3 is the line of symmetry, and that minimum is going to be on there, but the minimum is how low or high it is, and in this case low. and that's going to be the rest of the vertex. So let's finish finding the vertex, minus 3, and plug minus 3 into the equation. Negative 3 squared plus 6 times negative 3 plus 7. So this is negative 3 times negative 3 is 9. Negative 3 times 6 is minus 18 plus 7. That's negative 9 plus 7 is negative 2. So the minimum is negative 2. The line of symmetry is x equal minus 3. The vertex is negative 3, negative 2. When is this increasing? Well, since it's a right side up, it's from the vertex to the right. It'll be increasing. The vertex is at minus 3. So from negative 3 on to the right, it's increasing. And then it says determine when it's positive. Well, since it's going like this, it'll be positive. It'll be above the 0 for x is over here, and for x is over here, it'll be a height will be positive. So we got to find the x-intercepts. Now, if we could factor this, it would work out. Can we factor it? X squared plus 6x plus 7. That's only 7 and 1, and we'd have to subtract, but it's plus 7, so it doesn't factor. So we need to use the quadratic formula or the calculator. We can use the quadratic formula in the calculator, but I'm going to do it manually here for those of you who don't have it. So it's the opposite of b, plus or minus the square root of b squared, so that's 6 times 6, 36, minus 4 times 1, which is minus 4, times 7 is minus 28, over 2 times a, which is 2. 36 minus 28 is 8. So I have negative 6 plus or minus the square root of 8 over 2. And let's see, 8 is, I could leave it like this, and so minus 6 minus the square root of 8 over 2 would be the smaller one over here. So I want to be below that, so it's going to be from, for part E, it's going to be from minus infinity up to minus 6 minus the square root of 8 over 2. Union from the bigger one, which is minus 6 plus the square root of 8 over 2 to infinity. So there's the answer to that one. I can reduce this a little bit. See, the square root of 8 is 4. 8 is 4 times 2. Should be the square root of 4 and square root of 2. Square root of 4 is 2. So the minus 6 divided by 2 would be minus 3. And the 2 times the square root of 2 divided by 2 is going to be just plus or minus the square root of 2. So I could go from negative infinity up to negative 3 plus minus the square root of 2. Union from minus square root of 3 plus the square root of 2 to infinity. But that's how you do 4. 5. Greater than 0, this is a negative 4x squared, so it's an upside down parabola. It's going to be greater than 0 between the x-intercepts, where it's positive. It's negative over here. It's down below. So we just have to find the x-intercepts. So we forget the inequality and say we want to know when negative 4x squared plus 11x minus 5 is equal to 0, because we know we want to do outside those for when it's, no, in between those for when it's greater than 0. So factoring this can be a challenge with a negative here. So multiply through by a negative 1 and we get 4x squared minus 11x plus 5 equals 0. Notice no inequality sign here, just equal. And let's see, does this factor? If I do 2 and x and 2x, that would, if I put a 5 and a 1, I'll get 10 and 2, which is not 11. And it would add to be 12. If I put 4 and 1, I can get 20 and 1, which would be 21, not 11. Or I can put 4 times 5, 4 and 5 here would be 4 times 5 is 20, or I can put the 1 there, and 4 and 1 times 5 is 9. So it doesn't factor. So I'm stuck with using the quadratic formula to find these x-intercepts. And I can do this one, but it'll be easier if I use the positive on the x squared again. So the opposite of b, which would be the opposite of negative 11, is 11 plus or minus the square root of 11 squared, b squared. That's 121. Minus 4 times 4 is minus 16, times 5 is minus 80, over 2 times a, which is 4. So I got 11, and 121 minus 80 is 41. And there's not a nice square root of 41, so I'm going to have to go with 11 plus or minus the square root of 41 over 8. And I want to be between the two answers. The smaller one will be minus 11 plus 11 minus the square root of 41. 11 minus the square root of 41 over 8 has to be this left one. Up to the right one. Oh, and I want to be equal, so I'll have to use brackets on this. Up to 11 plus the square root of 41 over 8. So there's the answer for A. Now, if you just type the minus 4 and 11 and the minus 5 in the calculator, you would get the decimal approximations of those two, and you just would have been between the two. So it would have been a lot easier with the calculator for quadratic formula. But here it is longhand. This one, it's going to have a 3x times x, so that's 3x squared. That's a right side up parabola. Again, we're only interested when it's equal to 0, and then think about greater than 0. It's going to be out here where the parabola is greater than 0, and over here where the parabola is greater than 0. So we're going to go below one root and above the other. Now if I go 3x plus 4, since it's factor, and set that equal to 0, subtract 4 and I get 3x equals negative 4. Divide by 3 and I get x equals negative 4 thirds. That's one of these two. The other one is x minus 2 equal to 0. Add 2 to both sides. X equals 2. So that's bigger than that one. So this must be the 2. This must be the negative 4 thirds. I want to be below it where the parabola is greater than 0. So I got to go from negative infinity up to negative 4 thirds, not including, because it's not equal to 0, union from 2 to infinity. Six. It said, write a mathematical model for revenue, which is the number of items you sell times the price you sell them at. P times Q, or Q times P. And it says P is equal to 3,500 minus 5Q. That's what P is. So if you put this in the equation, you're replacing P. So P should come out. The Q would stay, so the revenue is going to be Q, that's staying, times P, which is going to be 3,500 minus 5Q. This is a function of Q. So if I find the vertex, it's going to be Q for the x coordinate, and R for the y coordinate. And it's going to be 3,500 q, distributing the q, minus 5q squared. So there's the model, or this one. And by finding the vertex, I'm going to be finding the q, which is c, the quantity that we want to sell. So I'm going to do negative b over 2a. So I'm going to have negative 3,500 over 2 times negative 5. So that's negative 10. So that's going to be negative 10 and negative 3,500 is 350. And that's the quantity, because this is a function of quantity. So it's 350 items that we're selling. To figure out the revenue, I can put that into this equation. But to figure out the price, I can go back to this original equation, 3,500 minus 5 times 350. 3,500 minus 5 times the 350 for the quantity. And so that's 3,500. 5 times that is minus 1,750, I believe. So this comes out to be 1,750 for the price per item. Because 3,500 minus 5q is the price. So there's the price, there's the number of items, and the revenue is number of items times the price, or we can plug that into the equation, but we can just multiply these two. 1,750 times 350, and we get 612,500, 612,500 in revenue. That's 6, 7. So we got to plot this. So I have to get up to, let's just go 0, 1, 2, 3, 4, 5, 6. That should fit most of the data, and it gets up to about 14. So if I go 2, 4, 6, 8, 10, 12, 14, that'll get most of the data, and 0. So 2.2, 2.2, 2.2, 2.2, 3.5, 4.2, 4, 5.2, 1.2, 1.4, 5.4, 8.9, 7, oh, that's over here, 14.5, and 0.7, that would be about there, 1.2 is about there, and 2.9, 3.1 is about there. And this very clearly makes a curve. So I've done A, made the scatter plot. So since it's curved, it's got to be a quadratic model. Because the data is curved. And so then with the calculator we can put in these numbers, and I've got the x's in there, and I need to put in 2.2, 4.2, 5.2, 1.4, 8.9, 14.5, 1.2, 3.1. To get to this place, I did stat, edit, and then put them in list 1 and 2. Then I do stat, calculate the quadratic using list 1 for my x's, comma, list 2 for my y's, comma, and if I want to see this, vars, put it into equation y1, enter. And it's going to tell me the equation is y equals a, which is 0.2999.3x squared, minus 0.19646 x, that's the b, and the c is plus 1.189 or something like that. Now, if you don't have a calculator to do this, you can get a easy app on your phone, or you can do it by hand. And on the other video for the other version of the test, I do it by hand. It takes quite a while, but you can watch that video and see how to do that.